Hi, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this present video, I would like to discuss the vector differentiation, and the present topic is some problems on gradient of a function and the divergence of a vector point function. In the previous class already we have seen the gradient of a function. So in this present video, I would like to do some problems on gradient of a function. So what is gradient? If f bar is any vector point function and phi is any scalar point function, and del can be applied on both vector and scalar point functions. And already I told del is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, and this is called the vector differential operator. Suppose if you del applied on scalar function means phi of x, y, z. Vector function means it is f1 I bar plus f2 j bar plus f3 k bar, where f1, f2, f3 are functions of x, y, z. Suppose if del applied, this is called del or nabla. If del applied on phi, then it is called grade phi. Gradient phi can be represented by grad phi. The grad phi is I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. And clearly, the physical interpretation of gradient is, if phi is any surface, then grad phi represents the normal vector to the surface. Suppose if any surface if it is a sphere, then grad phi is any sphere, then grad phi represents the normal vector to the surface. And also, to find the angle between two surfaces, we use grad phi. Suppose if there are two surfaces, and if you want to find the angle between the two surfaces, it is sufficient to find the angle between the two normals. The normals is first surface normal grad phi 1, second surface normal grad phi 2. Then cos theta formula n1 cap or n1 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. Then theta I can write cos inverse of this function. So the gradient application, you can find the angle between the vectors, and you can find the directional derivative also. Directional derivative means the rate of change of the vector scalar function phi in the direction of a bar is called the directional derivative. This is denoted by directional derivative, and it is defined as grad phi dot a bar by magnitude of a bar. And grad can be applied only on, the del can be applied on only scalar functions, then it is called gradient. Now we will see some more examples on gradient of the function. So already we have seen in the last class the angle between the two surfaces. The first one is a sphere and other one is another surface. We have to find the angle between the two surfaces. So angle between is grad phi 1. So suppose if phi 1 is assumed as x square plus y square plus z square minus 9, and phi 2, the second surface is z minus or x square plus y square minus z minus 3, then grad phi 1, that is I bar dou by dou x of this one, that is 2x, plus j bar dou by dou y of this one 2y, plus k bar dou by dou z of this one is 2z. And grad phi 1 at the point 2 minus 1, 2 is equal to, this is I bar plus j bar plus k bar. Clearly it is a vector. Grad phi 1 is a vector. So I am writing directly here. Or I can say that I will explain. Grad phi 1 means it is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function phi. That is I bar into dou by dou x of this whole thing, that is 2x. When you are doing partial derivative, dou by dou x of this one will be 2x and this will be 0 and this will be 0. Similarly, j bar into dou by dou y of this one, that is 2y plus k bar into 2z. This is grade phi 1 at any point. Then grad phi 1 at the point 2 minus 1, 2 is equal to 2 2's 4i bar minus 2j bar plus 4k bar. This is the first normal vector to the surface. First vector to the surface. Similarly, you can find grad phi 2. That is I bar into dou by dou x of this one 2x plus j bar into dou by dou y of this one 2y plus k bar into dou by dou z of this one minus 1. And grad phi 2 normal vector at the point 2 minus 1, 2 is equal to, so x plus 2, 2 into 2, 4i bar minus 2j bar minus k bar. This is the second vector n2 bar. So this is the first normal vector, this is the second normal vector to the corresponding surfaces. Then to find the angle between the two vectors, I can use the formula cos theta is equal to n1 bar into n2 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. So what is n1 bar here? This 4i bar minus 2j bar plus 4k bar dot product with what is n2 bar? 4i bar minus 2j bar minus k bar by modulus, same magnitude of n1 bar, that is square root of 16 plus 4 plus 16, and magnitude of this one is 16 plus 4 plus 1. So this is on making dot product, I bar dot I bar 1, j bar dot j bar 1, k bar dot k bar 1, remaining all are zeros. So on using this, you will get 16 plus 4 minus plus 4 minus 1 minus 4 by root 36 into root 21. So 16 by 6 root 21 or 2 8s, 2 3s. Or theta is equal to cos inverse of 8 by 3 root 21. This is the angle between the two normal vectors. Angle between the two normal vector means it is nothing but angle between the two surfaces. X square plus y square plus z square is equal to 9 and z is equal to x square plus y square minus 3. So in this way you can calculate using normal vectors the angle between the two surfaces at the given point. So this is one application of the gradient. Similarly, we have some rules here. So you can show that grad r power n. We have to show that it is a theorem. On applying del on r power n, you'll get n into r power n minus 2 into r bar, where r bar is xi bar. R bar is a vector which is xi bar plus yj bar plus zk bar, and also given r is a scalar function. R is a scalar function, that is magnitude of r bar, that is root of magnitude of this vector, root of x square plus y square plus z square. R is a scalar point function and r bar is a vector point function. Then our requirements are, you can calculate from this dou r by dou x. The partial derivative, r is different from r bar. R bar is a vector, r is a scalar function. Dou r by dou x, I am going to differentiate partially with respect to x. So I am differentiating 1 by 2 root of x square plus y square plus z square into, on differentiating inner term, x square derivative 2x, y square derivative 0, z square derivative 0. So 2 will get cancelled and this is equal to x by r. Dou r by dou x is equal to x by r. Similarly, dou r by dou y. Dou r by dou y means clearly r is a function of x, y, z. we can differentiate r with respect to x, with respect to y, with respect to z. Dou r by dou y, the same way to find 1 by 2 root x square plus y square plus z square into the value is equal to y, because we are differentiating partially with respect to y. So 2 also gets cancelled. This is equal to y by r. And what is dou r by dou z? Dou r by dou z is equal to z by r. So because r bar is a xi bar plus yj bar plus zk bar, and r is magnitude of r bar, which is root of x square plus y square plus z square, then dou r by dou x by r, dou r by dou y by r, dou r by dou z by r. Now, I consider what you have to show that grad r power n you have to consider, and you have to show that it is n into r power n minus 2 into r bar. What is grad? Grad means a del operator I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of r power n. R power n is a function of x, y, z. R means root of x square plus y square plus z square. R power n means x square plus y square plus z square whole power n by 2. Or simply we can say it as r power n and b as r power n. Then I am differentiating I bar dou by dou x of this one. Dou by dou x of r power n is a function of x, y, z. So you can differentiate with respect to x. So n into r power n minus 1 into dou r by dou x. See this clearly. I bar dou by dou x of r power n. N into r power n minus 1 into dou r by dou x, because r is a function of x, y and z terms, plus j bar into dou by dou y of the same thing, n into r power n minus 1 into dou r by dou y, that is the second term, plus k bar into dou by dou z of this one, n into r power n minus 1 into dou r by dou z. But what is dou r by dou x? Dou r by dou x is x by r. Already we have calculated. Dou r by dou y, y by r. Dou r by dou z is z by r. So substituting I bar into n into r power n minus 1 into x by r. Dou r by dou x is x by r. Plus j bar into n into r power n minus 1 into dou r by dou y is y by r. Plus k bar into n into r power n minus 1 into z by r. So now I can take out, what I can take out here, n r power n minus 1 by r, that is common term. I can take out n into r power n minus 1 into r power minus 1. R, on writing in the numerator r power minus 1. So in the first term, what you will get xi bar. In the second term, yj bar. In the third term, zk bar. I hope this is clear. N into r power n minus 1 by r. By r means r power minus 1. So this is equal to n into r power n minus 2. Already minus 1, n minus 1 is there, n minus 1 minus 1, n minus 2. And this whole thing can be written as r bar. So n into r power n minus 2 into r bar is the grad r power n value. So very simple. R bar is a function of x, y, z, and it is a vector function. And r is a function of x, y, z. It is a scalar function. Then we have to find grad r power n. Grad r power n means grad applied on scalar function. That is nothing but gradient. Del applied on scalar function. So on using the derivatives, partial derivatives, I can reach the solution as n into r power n minus 2 into r bar. This is an important theorem, and like that you can prove different theorems on using gradient. Here also, see another theorem. Here f bar is in, a bar is any constant vector. Constant vector means what? A bar is given, a bar is a constant vector. That is what I can assume a1 I bar plus a2 j bar plus a3 k bar, where a1, a2, a3 are constants. Constant vector means all the three values a1, a2, a3 are constants. If these are functions of x, then it is not constant. constant function. So it is a constant vector. And given that r bar is xi bar plus yj bar plus zk bar, it is a position vector of the point x comma y comma z. Then what we have to show that is grad a dot r bar. A bar is vector, r bar is vector. The dot product of these two vectors will be scalar. A bar dot r bar is a scalar. You have to find gradient of that scalar function and you have to show that the value is equal to a bar. Very simple proof. Now what is a bar dot r bar? Now what is a bar dot r bar? A bar is a1 I bar plus a2 j bar plus a3 k bar. A bar dot product with r bar. R bar means xi bar plus yj bar plus zk bar. Then what is the dot product? A1 x I bar dot I bar 1, I bar dot j bar 0, I bar dot k bar 0. Only you will get the first term A1x plus A2 j bar into y, A2 j bar dot product with yj bar. That means what? A2y. A2y. I j bar dot j bar 1. J bar dot k bar 0, j bar dot I bar 0. The remaining all are 0. So only j bar dot j bar 1. Similarly, k bar dot k bar 1. Remaining k bar dot I bar, k bar dot j bar 0. I am not considering I bar, j bar coefficients. Only I am considering A3z only. A3 k bar dot z k bar. K bar dot k bar 1 will get A3z. This is a bar dot r bar. It is a scalar point function. It is a scalar. Am I right or not? There is no I bar, j bar, k bar terms. So it is a scalar function. A1, A2, A3 are constants. We know that. Now consider what you have to consider. Grad a bar dot r bar. So this I am considering grad a bar dot r bar. So grad means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of a1x plus a2y plus a3z. So on operating each term with dou by dou x, you will get only a1. Dou by dou x of a1x a1. This is 0, this is 0. Similarly, j bar into dou by dou y of the entire function. With respect to y means constant, x is constant, z constant, these two are 0. Only you get a2y. So that is a2 plus k bar into dou by dou z of this one, that is equal to a3. Therefore, this is a1 I bar plus a2 j bar plus a3 k bar, that is equal to a bar. So grad a bar dot r bar is equal to a bar. Therefore, hence proved. Hence the theorem is proved. Grad a bar dot r bar is equal to grad a bar dot r bar is equal to a bar, where a bar is the vector a1 I bar plus a2 j bar plus a3 k bar, where a1, a2, a3 are constants. So in this way you can prove several theorems on the gradient. Very simple. And also you can see one more theorem here. It will be the last theorem on gradient. Then I will go to the divergence of a vector point function. So this also can be proved in the same way. F of r is a function of r, grad f of r. So what is given that r is xi bar plus yj bar plus zk bar and r is magnitude of r bar. So what are the given? R bar is xi I bar plus yj bar plus zk bar, and what is r? Magnitude of r bar, that is root of x square plus y square plus z square. Then what is dou r by dou x? Already you have seen in the previous problem. Dou r by dou x by r, dou r by dou y by r, and dou r by dou z is equal to z by r. These are common for all problems. Then what we have to consider? Grad f of r. Grad f of r. This is, I am considering the left hand side term, grad f of r. So what is grad? Del. Del means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of f of r. F of r is a function of r. What is r? R is root of x square plus y square plus z square. So f of r is a function of x, y, z. So on differentiating, dou by dou x of f of r. Dou by dou x of f of r. So the derivative is f dash of r. F of r derivative f dash of r into dou r by dou x. So I am writing here dou by dou x of f of r is f dash of r into dou r by dou x. Plus similarly j bar into dou by dou y of f of r. Dou by dou y and operating with f of r, we will get f dash of r into dou r by dou y. Similarly, what is the last one? Dou r by dou y. Plus, similarly, what is k bar into dou by dou z of f of r. So, this also gives the derivative f dash of r into dou r by dou z. So, what is the common term here? F dash of r you can take outside. I bar into dou r by dou x, x by r, plus j bar into dou r by dou y, y by r, plus k bar into f dash of r already taken outside, dou r by dou z is z by r. So, or I can write f dash of r by r, take outside the r value. So, in the bracket we will get xi bar plus yj bar plus zk bar. So, that is what you can write, the entire bracket term is r bar. So, f dash of r by r into r bar. So, this is the required solution, f dash of r by r into r bar. So, this is another theorem related to the gradient of the function. So, now I would like to define the divergence of a vector point function. Divergence of a vector point function. So, if del applied on scalar point function, it will be the gradient. If del applied on scalar function, that is called grad phi or gradient phi. Suppose if del is applied on a vector point function f bar such that the relation between its dot product del dot f bar, then it is called the divergence of f bar. If del can be applied on both scalar and vector functions. If del applied, del is a differential operator. If del is applied on vector point function f bar as a dot product, then the resultant will be a scalar, and this dot product is called divergence of f bar. So how to define? I'll read out. Let f bar be any vector point function. Then divergence of a vector point function f bar is denoted by div f bar. Simply you can write divergence of f bar as div f bar, and it is defined as div f bar is equal to del dot f bar. Div f bar is del dot f bar. This is the definition of the divergence. Suppose if f bar is a vector f1 I bar plus f2 j bar plus f3 k bar, where f1, f2, f3 are functions of x, y, z, where f1, f2, f3 are functions of x, y, z, then div f bar is equal to, div f bar means del dot f bar, del means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, the dot product with f1 I bar plus f2 j bar plus f3 k bar. So here you can say that I bar dot I bar is equal to 1, that is j bar dot j bar, that is k bar dot k bar. I bar dot I bar, j bar dot j bar, k bar dot k bar 1. Remaining I bar dot j bar dot I bar, k bar dot j bar, k bar dot some I bar, all are zeros. Remaining only these values are 1. So dou by dou x of f1, that is dou f1 by dou x, first value. Then I bar dot j bar 0, I bar dot k bar also 0. Those values need not to consider. Next j bar dot j bar 1. So dou f2 by dou y, that is the second term. Similarly, last one, dou f3 by dou z. So clearly there is no containing of I bar, j bar, k bar terms. So which is a scalar function. So the divergence of f bar is a scalar point function. So del f bar, del dot f bar is called the divergence, and it is denoted by div f bar. So the resultant of div f bar is always a scalar point function. Now, the physical interpretation of divergence. If v bar is the velocity of a fluid at a point x comma y z, x comma y comma z and time t, then div v bar, divergence of v bar represents, what it represents? The rate of outflow per unit volume at the point of the horizon. So it indicates the rate of outflow per unit volume at the point of horizon is denoted by div v bar. Clearly it is the physical phenomena, divergence, gradient, and then another one is curl of a vector point function. So if v bar is the velocity vector of the fluid at a point x comma y comma z, if you want to calculate dive v bar, then dive v bar represents the rate of outflow per unit volume at the point of origin. Then here we have another definition on solenoidal vector. A vector point function f bar is said to be solenoidal if dive f bar is equal to 0. So dive f bar is always scalar. That means it is 0. You suppose if curl f bar 0, then you have to write it as 0 bar. So dive f bar means it is a scalar value. So dive f bar, if it is 0, then the vector f bar is said to be a solenoidal vector. So on this divergence, you have the different properties and to showing of solenoidal vector and finding of the p-value when it is a solenoidal vector, like that. So we will perform some problems on the divergence also, like gradient. So see the first problem. So read out, if f bar is xy I bar plus yz j bar plus zx k bar, then find dive f bar at the point 1, 2, 3. So very simple problem. Already given f bar is a function as a vector point function xy I bar plus yz j bar plus zx k bar. Consider dive f bar. Dive f bar means del dot f bar. So del means the differential operator I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product with the function f bar xy I bar plus yz j bar plus zx k bar. That is I bar dot I bar 1, again dou by dou x of xy first term, dou by dou y of yz second term, because j bar dot j bar 1, plus k bar dot k bar 1, dou by dou z of zx. So this is dou by dou x of xy, partial derivative of this function with respect to x. So y constant. So x will become 1 into y, that is y first term. The partial derivative of this function with respect to y, so z will be the constant, z is the value, plus dou by dou z of zx, z1 no x. So y plus z plus x, or x plus y plus z is the divergence of f bar. Clearly it is a scalar function. There is no I bar, j bar, k bar terms. Clearly it is x plus y plus z. Now we need to calculate dive f bar at this point 1, 2, 3. So substitute x for 1, y for 2, z for 3. Then y is equal to 2, z is equal to 3, x is equal to 1. So the value of dive f bar is equal to 6. Dive f bar value is always a scalar value. So at the point becomes it is a some real constant. Right. So we go to another problem. Show that dive r bar is equal to 3. Very simple results. We know that r bar is standard. R bar is what is? It is a position vector of any point xi bar plus yj bar plus zk bar. So if they were not mentioned what is r bar, you have to assume that r bar is xi bar plus yj bar plus zk bar. Then dive r bar is equal to del dot r bar. So del means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product with r bar is xi bar plus yj bar plus zk bar. So I'm using the dot product I bar dot I bar 1 and j bar dot j bar 1, k bar dot k bar 1. So dou by dou x of x plus dou by dou y of y plus dou by dou z of z. The values are 1 plus 1 plus 1, that is equal to 3. So dive r bar is equal to 3. This is a standard result. Dive r bar is equal to 3. Similarly, if f bar, third problem, if f bar is equal to the given vector point function is solenoidal, already as given it is a solenoidal vector function, then find the value of p. So p is unknown quantity is there, that you have to assume. P value you have to find out finally. So as usual, given f bar is the vector, since f bar is solenoidal, what we have by the definition, if f bar is a solenoidal vector, then dive f bar is equal to 0. So dive f bar means del dot f bar. Del dot f bar, del means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. Dot product with the given vector x plus 3y into I bar plus y minus 2z into j bar plus x plus pz into k bar is equal to 0. So I'm making dot product I bar dot I bar 1. So the value will become dou by dou x of x plus 3y, first term. dou by dou x of x plus 3y plus j bar dot j bar 1 dou by dou y of y minus 2z plus k bar dot k bar 1 dou by dou z of x plus pz. So on differentiating partially, dou by dou x of this entire term is 1, x derivative 1 and y derivative will be 0. So totally it is plus 1 only. Then dou by dou y of this entire term 1, this is 0. So 1 you got final value. Dou by dou z of this one, dou by dou z of x is 0 and this value with respect to z means z1 the value p will obtain. So 1 plus p is equal to 0 or p plus 2 is equal to 0 or p is equal to minus 2, which is the value of the unknown value in the given function if the vector is a solenoidal vector point function. Now I would like to do one problem on divergence. Divergence of r bar by r is equal to 2 by r, where r bar is xi bar plus yj bar plus zk bar. This is the last problem of the topic divergence of a vector point function. So already we have seen r bar xi bar plus yj bar plus zk bar and r is equal to magnitude of r bar. So everything clear. So I will write once again given solution. Given r bar is xi bar plus yj bar plus zk bar and r is equal to magnitude of r bar, that is root of x square plus y square plus z square. And what are the elements? Already we know dou r by dou x by r, dou r by dou y by r and dou r by dou z is equal to z by r. So already these values, how to get these values already explained in the previous problems. So now div r bar by r, div r bar by r. What is r? R is function of x, y, z. That is del dot r bar by r. That is del means what? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product with r bar by r. R bar means xi bar plus yj bar plus zk bar. So I can write it as x by r into I bar plus y by r into j bar plus z by r into k bar. I think this is clear. Del, that is a vector differential operator, I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product of the vector r bar by r. R bar means xi bar plus yj bar plus zk bar. So I bar coefficient x by r, y bar coefficient, j bar coefficient y by r, k bar coefficient z by r. Now make the dot product. Dou by dou x of, what is the value? X by r. Similarly, dou by dou y of y by r plus dou by dou z of z by r. So this I can write it as summation dou by dou x of x by r. Summation dou by dou x of x by r. So clearly it is looking like u by v form because x is already a function of x. R is also a function of x, y, z. So I need to apply u by v form. So what is the formula? Summation dou by dou x of x by r is summation symbol right as it is. Undoing the derivative x using the formula u by v, r square into r into 1 minus x into dou r by dou x. I'm using the summation notation because instead of writing all the three terms each time, I use this notation summation dou by dou x of x by r. So x by r derivative. So it is u by r formula or u by v formula, v square. Already I have written x r square. So here r into 1 minus x into dou r by dou x. But what is dou r by dou x? X by r. So this is summation r minus x into x by r square. So this is summation r square minus x square by r square into r. That is r cube. Am I right? This is r square minus x square by r square into r cube. So I can write it here directly in the denominator. It is r cube. So I hope this is clear. Summation r minus x square by r. That means r square minus x square by r square into r cube. So in explaining this for the three terms, this is only for x term, y term, z term. So in explaining this, I can write r square minus x square by r cube first term, second term r square minus y square by r cube, plus for z term r square minus z square by r cube. So now finally on adding all the three terms, 1 by r cube is common term, 1 by r cube. Here r square minus x square plus r square minus y square plus r square minus z square. And expanding the sigma for the three terms, y square one term, x square one term, for z square is another term. That is 1 by r cube into, here r square plus r square plus r square, that is equal to 3r square, minus of x square plus y square plus z square. But what is r square plus x square plus y square plus z square is r square. That is equal to 2r square by r cube. That is equal to 2 by r, which is the required RHS. The resultant is 2 by r. So just here there is a small calculation here. Other than everything is as usual. So just we have calculated r bar by r value, that is xi bar plus yj bar plus zk bar by r. That means I am writing I bar coefficient x by r, y bar coefficient y by r, j bar coefficient y by r, k bar coefficient z by r. So each are applying with the del as a dot operation, will get to finally 2 by r. So this is the problem or property related to the this divergence of a vector point function. So in the next class, I will explain the divergence. After divergence, we will have the curl of a vector point function and some identities to prove the results. Some of the operations with the del square. Del square means it is called the Laplacian operator, and that I will explain in the next video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.